Hello again, this is Mr. Duncan. Today, I want to explain how to do division with fractions from a measurement perspective. What that means is if we're doing division, measurement division, is that we start off with some amount of stuff, and we want to see how many groups of this size we can make with this amount of stuff. So here we have 2 1/5 units, and we want to know how many groups we can make that are 3/4 of a unit big. So first of all, we need to draw our 2 1/5 units. So we will do that first. Let's go ahead and do that. Okay, so there's one hole. I need another hole, same size. And now I need to make a piece that's 1/5 the size of these pieces. So I will draw out the same size hole again. This time I'm going to use dotted lines. You'll see why in a minute. And then I need to partition this into 5 equal-sized pieces, and I just need one of those. So let's go. There's 1, there's 2, there's 3, there's 4, and there's 5. 1, 2, 3, 4, 5. So this one's solid. This means that I have one piece, and if I had 5 pieces that were the same size as this one piece, 1, 2, 3, 4, 5, if I had all 5 of them, it would make a whole. So this is 1/5 of a unit. So let's go ahead and label this. It is always recommended that you label what your units are. Illustrate your pictures. Whether you're working on a problem yourself, it makes it easier for you to keep track of what you've done, what your quantities are. It keeps track of everything for you without you having to do a whole lot of cognitive overload. The other thing is if you are trying to teach somebody this concept, if you're trying to teach your child or a student, maybe in elementary or middle school, it makes it easier for them to follow what you've done. They can see all of the quantities. They can see where the numbers show up. These symbols now have actual representation. They can see all these things. So it makes it much easier for the learner to follow what's going on. Okay, so we have 2 1/5 units. What we want to know is how many of these can we make with this much stuff? How many 3/4 size pieces can we make with 2 1/5? So let's go ahead and see what that 3/4 looks like. It's going to be the same size as our other hole, so I'm going to first draw it as using a dotted line. And then I need to partition it into 4 equal-sized pieces. So let's make 4 equal-sized pieces. There's 2, there's 3, and now we have 4. And we need to consider 3 of them. So this right here, this is our group. And let's represent it so we can see all 3 pieces. So we have 3 pieces. If we had 4 equal-sized pieces of this size, it would make one of our holes. Because now we can see it's the same size as one of our holes that we have. Okay. So our question is, how many of these guys would it take, can we make from these pieces that we have? How many of these groups can we make with just this amount of stuff? All right, so right now we have a total of 2 1/5 units. I'm going to write that here, keep track. So here's my 2 1/5 unit. Here I have a group, one group. So one group is size 3/4. Okay, so every time you get 3/4, that's one group. Okay, fair enough. So here comes the dilemma. These pieces are not the same size as these pieces. So these pieces are all in terms of fourths. There's 3 of them, and it would take 4 to make a whole. Here we have a whole, and a 1/5. Well, we can clean this up right away, and this is always a nice strategy. Let's go ahead and make our quantity that we actually have. Let's make it the same size pieces. Right now we have a whole, and a 1/5. Let's make them all the same size. Well, since this is a 1/5, we can partition our holes so that they're 1/5s as well. Let's go ahead and do that, and let's use this color. So we're going to partition each of our holes into 1/5s. Okay. So there's 1, there's 2, there's 3, and there is 4. 5. 1, 2, 3, 4, 5. There's 5ths there. Do the same thing here. 1, 2, 3, 4, and 5. So now we have our holes, or our quantity is now partitioned into 5ths. Both of our holes, and then we already had a 5th. So now we have 5 plus another 5, that's 10 plus 1. We have 11 pieces, and it would take 5 of them to make a hole. See, there's 5 of them. Here it makes one hole. So we can say now that we have 11 fifths, or 11 1/5 size pieces. That's what we have here. You can see there's 11 of them. 5 plus another 5 is 10, plus 1 is 11. Okay, so we have 11 fifths. Now, does that solve our problem? Well, the answer is no. These, we have 3 of them. They're all fourths. In size, 4 of them would make a whole. These, it takes 5 of them to make a whole. So they are not the same size, right? If this took 5 of these to make a whole, then these pieces would be the same size as these pieces. But they're not. And that's what the denominator of a number really means. It tells you how big each of the pieces you have is. So here, I have 11 pieces. How big are they? Well, it would take 5 of them to make a whole. So that tells you how big any one of these pieces are. All of them are the same size. And it takes 5 of them to make a whole. So our dilemma is still in place. We now have 3/4. That's how big a group would be. But our pieces aren't in the same size. They're not all in quarters. They're in fifths. What we need to do is make it so that our pieces here and our pieces here are the same size. So that is our job. Okay, and I'll put that here. We need same-sized pieces. Okay, so that's problematic for us right now. The way we resolve this issue is we can partition. Notice how we partitioned our whole into fifths. Well, what says we can't partition our pieces even further if we wanted to? So if I wanted to, I could cut each of my 1/5 in half. If I did that, I'll get 2 pieces each. And that would give me 10 pieces, making up a whole. So I would have tenths. So I could do that. I could make my fifths into tenths by partitioning or subdividing each piece into 2 pieces. Does that help me here? Well, these are in terms of fourths. These would then be in terms of tenths. Those still are not the same size. What we need is a common partition. So that is our fix. So in order to get same-sized pieces, we need, or we will find, a common partitioning. And what that means is a partitioning that will make these pieces and a partitioning that will make these pieces the same size. Another way we describe a common partitioning in mathematical language is we're finding a common denominator. And that makes sense. We're finding a partitioning that will make our pieces the same size. If the denominator is the same, that's why we use the word common. It means it's the same thing. It's common. We have the same denominator in common. If that was the case, that would mean that these pieces were the same size, because that's what denominator means to us. It means how big the pieces are. So if I keep cutting up my pieces, and half doesn't work. If I cut it up into 3 pieces each, that would be 15 pieces making a whole. Still, that's not going to work. The first common partition that will work is 20. If I cut my fifths into fourths each, 4 pieces each, I will have 20 pieces. If I take my fourths here and I cut them up into 5 pieces each, I'll get 20ths down here, 20 pieces. That is our first partitioning that's common to both. So let's go ahead and list that. I'll put that in green here. We can partition both our fifths, I'll write them as fifths, okay, and the word, and our fourths into 20ths. Okay. Now, my explanation here written is not going to be a perfect explanation. I'm just putting footnotes really here. A full explanation would say why we're doing what we're doing, explaining each of the steps, and then giving our reasons for what we do. I'm not just going to put an algorithm of do this, do this, do this, do this. That's just a how-to list. Really what we need is what do I do, and why am I doing it, and how does that help me do the next thing, and what should I do from there? That's the real goal when we make a good explanation. So right now we need to partition our fifths and our fourths so we end up with 20ths because that's a common partition. So we're going to cut up our fifths into 4 parts each. I'll use a red ink so you can see that. 4 parts each. It'll be easier if I just do a lattice method. So instead of doing it vertically, I'm going to make partitions that are horizontal. So I need to cut these up into 4 equal sized pieces, my fifths. So there's 2, 3, and 4. And you can see I now should have 1, 2, 3, 4, 4 times 5. So there's 5 columns here, and there's 4 pieces each. So that should be 20 pieces make up my whole. So it's very easy to see now. I've taken my fifths and I've converted them into 20ths. And I'm going to do that for all of my fifths, so that I have a uniformity across. All of my pieces are now the same size. So now I have 20 here, 20 here, and then 1, 2, 3, 4 here. So I end up with 24 pieces. 24 pieces. And how big are they? Well, here's our whole. How many pieces does it take to make a whole? It takes 20 of them. So these are 20ths. 20th size pieces. Okay, I have 24 pieces, and it takes 20 to make a whole. Okay, great. Now we need to do the same type of part. Well, we need to do another partitioning for our quarters so that we end up with the same size. We want 20ths. So that means I'm going to need to partition these pieces into 5 pieces each. Each of these into 5 pieces each. So let's go ahead and do that, and I'll use the red ink again. So 5 pieces each. There's 1, there's 2, 3, there's 4, and there's 5. And I'll put dotted lines across. Okay, because we don't have this piece. That's not a piece that we actually have. So our 3/4 is now become 5, 10, 15 pieces, where 20 would make a whole. You can see there's 20 pieces here. So our 3/4 is now, I'll put or, has now become 5, 10, 15 20ths. So we can see those fractions are equivalent. Okay, so now I need to make groups that have 15 of these 20th size pieces in them. Well, all my pieces are 20ths in size, so I just need to take them 15 at a time. How many groups of 15 can I make? Well, it seems I can make one group, right? That'd be 15 pieces. That would just be, and then I'd be left with 9 pieces. So I can actually visualize that. I can draw that if we so need. If we want to show 15 pieces, I could color in 15 at a time. In fact, that's not so hard. I suppose we could take care of that. There's 5, there's 10, there's 15, there's one group right there. And then, why do we have not enough pieces here? Oh, I see, 20, 40, that should be 44. That number should be 44. I apologize, folks. This, not 24, that would make no sense. This number should be 44. Our quantity here should be 44. 20 plus 20 plus 4, 44. So there's 5, 10, 15 pieces. That's one of these groups. All right, we want to see how many of these we can make. Well, every time we have 15 pieces, that's one group. So there's one. Let's change colors again. Let's, here, we'll use this dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's another group. And here I'm going to pause because we now have 2 full groups of 15. I now have 5, 10, 11, 12, 13, 14 pieces. I don't have enough to make a third group. Okay, so I end up with 2 groups of size, and I can say 15 20ths, of size 15 20ths, or, which we know that's the same as 3/4. That's the same thing. So it takes 15 of these pieces to make one of these groups. Okay, 15 pieces, but I don't have enough to make another group. I only have 14 pieces. So I don't have a full group. Instead, I have 14 15ths of a group of size 15. Can we see that? Yeah, of 15 20ths. Or you can call it 3/4. It's the same thing. Okay, can you see that? Take a moment. Make sure you see that. Here's one group of 15 20ths, which is the same as 3/4 to us, and it makes sense because you can see 1, 2, 3, 4. There, you can see we could look at this as those are now partitioned into fourths, so that'd be 3/4 right there. Right here, there's 3 bars, right? Each row would be 1/4. So there's 3/4. There's one group of 3/4, which we want to make groups of 3/4. 1, 2, 3. There's another group of 3/4, and then we have 5, 10, 11, 12, 13, 14. We don't have enough because we need 15 pieces to make one of these groups, right? One group requires 15 pieces. We only have 14 pieces. So we don't have 15, so we have a fractional amount of our group. we don't have 15/15ths, which would be one whole. We have 14/15ths, because there's only 14 pieces, and it takes 15 to make a full group. So we have 14/15ths of a group of size 15/20ths, or 3/4. And if we add these two up, we end up with our answer of 2 and 14/15ths groups. Each of these, of course, are of size 3/4, or 15/20ths, right? Because that's the same thing. We know those quantities are the same. So this is our answer. We have found our answer. Now, even though we've done the work, and hopefully it should appear very sensible how we started with 2 1/5, we made groups of this big, and we made them, of course, we need to make sure the pieces are the same size so we could easily make these size groups. This process should be straightforward. It should be easy to follow. However, I know that I was not taught this growing up. What I was taught was if you wanted to do fraction division, you took your quantity here, and you, instead of dividing by 3/4, you would multiply by the reciprocal, which means flipping this number over and multiplying by it. So we would have 2 1/5 times 4/3, and that's how you came up with your answer. Well, I don't think we need to do that. However, I do want you to see that our answer is genuine, that it does work, that it follows exactly what we would want it to, and so we will do the very operation that we were taught originally just to confirm that this is, in fact, the answer we want. So our old method that we were taught, and let's do this in blue so it's a different color, is to take 2 1/5 and to multiply it by the reciprocal of 3/4. The reciprocal would be 4/3. It's inverting that number. By the way, if you want to know why we're allowed to invert and multiply, there's another video I have that you can watch, and it'll tell you, it should show you very clearly what we're doing here, why we're allowed to invert that number like that. So here's the process. We have 2 1/5 times 4/3. Well, we know if we're going to multiply these two terms, the easiest way is to make this into an improper fraction. So 2 times 5, that's 10, plus the one that's 11/5. So this becomes 11/5. And we now know why that's 11/5, because we saw it up here, right? We took our two holes, and partitioned them into fifths originally, and we found we had 5, 10, and then another 1 that's 11/5. So here's our 11/5, and we multiply by 4/3. And when it comes to the algorithm, or the steps you're taught to use when it comes to multiplying fractions, you multiply the numerators, and if we do that, where's our pen? If we do that, we end up with 11 times 44 is 44. 11 times 4 is 44. 5 times 3 is 15. Okay, 44/15. Now, if we wish to simplify that and write it as a mixed number, we'd see 44 divided by 15. Well, 44 divided by 15 will give us, that's 2. That's equal to 2, because 15 times 2 is 30. 15 times 3 would be 45. That's too much. We don't have that much. So we can get 2 out, and that's 30. 44 minus 30 is 14. So we're left with 14, a remainder of 14, or 14/15. As you can easily see, this quantity is exactly what we ended up with here. The difference is, here, you probably couldn't tell me what this unit is. 2 and 14/15 what? What is this? What does this quantity mean? Here it's very clear that we've made this many groups of this size. That's what our job was. We made this many groups of this size. It comes out very clearly and easily. Now, I want to bring up one last thing, and then we'll call it quits for this video. Originally, we got 44/15. Why don't we see 44/15 originally? Let's see if we do. Can we see 44/15 in the process that we used? Well, let's go back to our picture. Our big dilemma was we needed same size pieces. Well, we found that if we made them into 20ths, we had same size pieces. Our 4ths became 15/20ths, and our 5ths became 44/20ths. And we said we need to take these 44 pieces and group them 15 at a time, or take 44 and divide by 15. So really, we did do that operation. We did it implicitly. We broke it up into parts, right? We said we'll just count how many groups of 15. We counted up until we round out of groups of 15. That's what we did here. But we could have done 44 divided by 15, right? 44 made into groups of size 15. We could have done that. and we would have gotten the same answer, 44/15. So there you have it. Here is the method we can use to show how to take 2 1/5 units and make groups that are this big, 3/4. How many groups can we make of 2 1/5 units? The answer is 2 14/15 groups of size 3/4, which is the same, of course, as size 15/20. And we're done.